The diagram on the left shows a device firing ball bearings at a barrier, with a screen recording their location behind. Now, classical mechanics would say that the ball bearings would either hit the barrier or go through the gap and hit the screen behind, matching up with the gaps in the barrier. And this is exactly what happens with ball bearings, as the diagram shows. Now look at the diagram on the right. This is illustrating a wave of water hitting the same barrier. Now as the water hits the barrier and moves through the two gaps, the water splits into two waves on the other side. And the peaks will combine to make a higher wave, or the lower points would combine, or a peak will meet a low point and be cancelled out. This would form the pattern seen on the screen at the back, exactly as predicted by classical mechanics, as the two waves interfere with each other and therefore create the interference pattern seen on the screen. Again, this is exactly what happens with water. Now let's change the ball bearings for a subatomic particle like an electron. Now on the left we have a device firing electrons instead of ball bearings. Now this is where something very weird happens. The detector at the back records the electrons hitting the screen all over the place, including the very area blocked by the barrier, as if the particle was a wave. But we are certain it's an electron, which is a particle, so how is this so, unless the electron is behaving like a wave at the same time as behaving like a particle? It took some of the greatest physicists ever known to theorize what's happening here. The electron is neither a particle or a wave, and it is both also. As confusing as this may seem, this is actually the way nature works. The cause of this is something called a probability wave, and the size of the wave at any location predicts the likelihood of the electron being found there. So the electron can literally be anywhere until you look for it. There is no certainty, and it's all about probability, something that totally goes head to head with classical mechanics. This has been confirmed time and time again, and the equations of quantum mechanics turn out to be incredibly accurate. The phenomenon is known as wave-particle duality. The diagram on the right illustrates how this works. One person who didn't like this idea was Albert Einstein, who believed in certainty and thought that quantum mechanics was incomplete and famously said that God does not throw dice. However, lots of other physicists weren't so put off by probability, as the equations of quantum mechanics gave them the ability to predict the behaviour of countless amounts of subatomic particles, and this quickly led to some huge inventions, like lasers, integrated circuits, and the entire field of electronics. Without quantum mechanics, we'd still be back in the Victorian era, with steam engines, which in my opinion wouldn't be a bad thing.